Hello, my name is Nick Sajapur, and I'm a senior coastal scientist with GHD. I'll be talking with you today about emerging science related to sediment dynamics in the Oceanside region and how this information is being integrated into designs for the ReBeach design competition. And I'll walk through how our project team is developing an adaptive sediment management program made up of complementary strategies that will optimize the efficacy of any concept that moves forward as part of ReBeach. Our project team feels it is important to give some context around how management activities integrate and complement the ReBeach effort. Given the dynamic nature of the coast, adaptive sediment management will be necessary for any project that moves forward to ensure that shoreline benefits are as broad, effective, and efficient as possible. To accomplish this, we have three key strategies that are being pursued in concert with the ReBeach design competition. They are to increase sediment supply to the coast, to better utilize existing sediment resources and management practices, and to set up a management program that is adaptable and nimble to adjust to shoreline changes as they occur. Increasing sediment supply to the coast will not only benefit any project that comes out of ReBeach, but will also have far-reaching benefits across Oceanside's shoreline. One component of this current project is the city is pursuing its own offshore exploration in hopes of finding a low-cost, long-term sand source for future nourishment projects. Additionally, the city is participating in the Sandag Regional Beach Sand 3 project, which is a countywide program hoping to leverage the shared need for beach sand across communities. Additionally, a separate U.S. Army Corps of Engineers oceanside mitigation study is in the works, which will likely result in another beach nourishment program that benefits Oceanside. Again, I want to emphasize that these actions will take place regardless of which design is selected as the winner of the ReBeach design competition. Our team has taken a look at what current actions could be modified to produce better results for Oceanside's beaches. The Oceanside Harbor is dredged annually by the Army Corps of Engineers. Currently, this program occurs in the late spring, early summer, right before the start of the South Swell season. Typically, the material is mostly placed between the Oceanside Harbor and the Oceanside Pier, with some sand making it just to the south side of the Oceanside Pier. Unfortunately, this placement location and timing before South Swell season typically results with material being pushed northward soon after it's placed, limiting the benefits to Oceanside's beaches. Through phase one, GHD explored several possible pipeline systems and currently is assessing how some of these concepts may be feasible to modify the delivery of the annual dredge material in a cost-effective way to get the material further south than it is currently is placed and increase the benefits of this regularly occurring program. The project team sees this as low-hanging fruit that again can be explored and implemented in concert with any of the designs that move forward as part of ReBeach, and this will have multiple benefits to the broader stretch of Oceanside's coastline. And of course, the adaptive piece of adaptive sediment management means we'll need to monitor the beaches to determine how they are responding to our management activities, the wave conditions, and modify elements of our management accordingly. Given the parallel nature of the multiple projects I just spoke of that are looking to increase the supply of sediment to the coastal system and the modification of existing management practices, our goal is to develop and implement an adaptive program that can be responsive to the performance of any intervention that moves forward through ReBeach to ensure that the desired metrics and performance goals are met. Currently, the city is supporting a community science monitoring program in coordination with the Scripps Institution of Oceanography to perform monthly beach surveys along the Oceanside coast. This program started in the fall of 2020 and can provide critical data to support baseline conditions for the ReBeach pilot project and help analyze trends in beach width and the response to natural events and management actions that occur. Speaking of monitoring, I'm going to now talk about some emerging research that is providing new insight into how our coastal system works. Stepping back a bit, I'll be talking about sand and sediment movement along the coast. Now, some of you may have heard before about littoral or littoral cells. Well, you could say littoral or littoral, but a littoral cell is a conceptual compartment that contains all of the sources and sinks of sediment. You could think of this as a watershed, but for sand. These compartments help us understand the flow of sediment resources on the coast. In Southern California, most of the sediment supply to the coast is from rivers, creeks, the watersheds that feed those rivers and creeks, and from eroding bluffs. However, due to the damming and channelization of rivers for water resource management and flood control, as well as coastal and watershed development, the supply of sediment to the system has been significantly reduced. If we zoom in to our project site, the main system in North County, San Diego is called the Oceanside Littoral Cell. The traditional view of the Oceanside Littoral Cell is that sediment inputs and outputs were contained between Dana Point and La Jolla. The assumption has been that sediment moves southward during the winter, northward during the summer, with the net dominant direction being a southward movement of sand. Several studies have used inlet dredging volumes to determine sediment transport rates, and those magnitudes have varied by study, all with them showing a net southward transport. In addition to the seasonal change in swell, coastal orientation has been a well-documented factor in transport mechanisms. Specifically, Oceanside's orientation exposes it more to south swells that typically occur in the summertime compared to the northwest swells, which occur in the fall and winter. While the littoral cell concepts and magnitudes on sediment transport have been long-standing assumptions, the robust buoy network in California, along with shoreline monitoring data, provided some indication that there might be some more nuances within the oceanside littoral cell. The 2009 Sandag Coastal Regional Sediment Management Plan introduced the concept of subcells within the oceanside littoral cell. The plan called for more research and investigation into the significance of potentially smaller compartments in the oceanside littoral cell and how seasonality could be an important factor to consider in planning future coastal projects. New analysis from wave and beach observations by Dr. Bill O'Reilly at Scripps Institution of Oceanography has indicated that the Oceanside littoral cell appears to operate in 8 subcells between the Oceanside Harbor and the Scripps Submarine Canyon in La Jolla. These subcells are primarily separated at lagoon mouths or inlets. It's been observed that other factors also play a role in sediment transport across the subcells, including offshore reefs, coastal orientation, as we spoke about, wave shadowing from the Channel Islands, and potentially other offshore features such as the Carlsbad Submarine Canyon. Observational data on waves from offshore buoys and beach positions from regular surveys can be correlated to determine patterns between wave conditions and beach responses. This data can further be filtered to tease out trends, such as how different types of wave events are connected to specific beach responses over time. This analysis produces directional wave-driven sediment transport potential. That means that observed waves and beaches across time indicate the potential to move sediment relatively to the north or to the south. This graph illustrates this net relative transport potential with red indicating northward transport, blue indicating southward transport, and white indicating net neutral directional movement. Additionally, the intensity of the color corresponds with the relative magnitude, meaning lighter shades show weaker potential transport, while darker shades indicate stronger transport potential. If we zoom into the oceanside subcell, we can see that the colors are much lighter in comparison to the other areas. This illustrates that the oceanside subcell has the weaker annual total potential wave-driven sand transport compared to the other subcells. As you move southward, you can detect a trend where transport maximum southward transport rates across the littoral cell increase as you go from the north in Oceanside to the south at Scripps Submarine Canyon. A 20-year analysis of the Oceanside subcell has indicated that on average, the coastal orientation leads to an annual net sediment transport to the north. Additionally, trends between wave parameters were also detected in reviewing the last 20 years of observations. Swell, meaning waves with periods longer than 11 seconds, on average supported more northward transport, while local seas, meaning waves with periods shorter than 11 seconds, on average supported more southward transport. So you might be asking, what is the difference between local seas and swell? Well, both local seas and swell are generated by wind blowing over water. Local seas are waves generated from storms close to the coast, and swell is a result of waves generated from storms far from the coast, thousands of miles away in the North or South Pacific. There are several parameters that are used to describe waves, as you can see on this diagram. As we mentioned in the previous slide, the time it takes for two successive crests is called the wave period. Local seas have a shorter period, where the time between crests is less than 11 seconds, where swell has a longer period. Time between crests is more than 11 seconds. These images are demonstrative of what you might see at the beach during these different wave events. Local seas may look like Victory at sea with heavy onshore wind, while swell could look like Groom corduroy lines. Putting this trend on a map can illustrate the mechanism more clearly. Again, a 20-year analysis of Oceanside subcell indicated that swell, meaning waves with periods longer than 11 seconds, on average supported a more northward transport, while local seas, meaning waves with periods shorter than 11 seconds, on average supported more southward transport. And on average in the Oceanside littoral cell, there was a slight northward dominance of potential sediment transport detected over a 20-year hindcast analysis. So thank you so much for taking interest in coastal dynamics and the ReBeach project. Our goal is to weave together the updated analysis of sediment transport, generate redundancies in a sand management approach that can be curated to meet the needs at hand, and have a coastal management vision that is informed by an active and robust monitoring program. Please visit our project website at rebeach.org to learn more about our project. Thank you so much.